Hello and welcome to the section 10.4 lecture today. Today we're going to be looking at factoring trinomials. So again, factoring is the reverse process of multiplying. It's almost like dividing, but it's like saying, hey, I want to factor the number 100. Well, 100 is 10 times 10, and each 10 is 2 times 5. So you're splitting it up into all the things that can be multiplied to give you the number that you want. In this case, we're trying to factor trinomials, so we have three terms, and typically with the highest power of x squared. One thing to keep in mind, because I'm going to be using the wrong end of my pen apparently, we're going to be looking at trinomials, and the standard form of trinomial is ax squared plus bx plus c. We're going to need to know what are in those individual spots in a lot of the work that we do today. And you may have learned this topic before. I'm looking at probably a completely new way, because I've found that sometimes when you just say the same thing over again, it doesn't really work. So we need an alternative method to look at these. So the way that I use in here is called the Australian method, and sometimes I use it, when I've got some difficult problems. Sometimes I don't. I just come up with the answer, but that kind of comes from, or I should say, the Australian method would work there, and it would work just fine. So let's go ahead and jump right into it. We've got a lot of problems to look at today, because I do feel like some repetition can definitely help. I've also got a calculator off to the side because we're going to need it as we get going through here. And every single time, I don't put this on every problem, but I need to find, or at least be thinking about, these numbers. I need two numbers that multiply to a times c. And so in this case, my a is 1 and my c is -3. So that they multiply to -3 and add up to the middle number. And this is pretty true no matter what system you use to factor trinomials. You're always looking at things that multiply to give you a times c, or most of the time we say, well, multiply the last number, add to the middle number. That just doesn't work if I have something else in front. So I've kind of combined what usually takes a couple days in math classes into one day. And I think this method does that very well. The beauty with this one is I don't have a whole lot of options for things that multiply to 3 that also add to 2. And I want to think of things that multiply to -3 first. Okay, so that could be a -3 and a +1, or a -1 and a +3. Those are really my only options there. Now, as we get to more complicated problems, they're going to have more possibilities that get us to that. That get us to that a times c. A lot of people would kind of look at this as a variation of what we call the AC method. So now what I want to look at is, what do these two numbers add up to? -3 plus 1 is going to give me -2, while -1 plus 3 is going to give me +2. And so it's the +2 that I'm looking for. So these two numbers are going to be the ones. In the Australian method, we now take those two, and I have x minus 1 times x plus 3. And kind of the technical step in the Australian method is that I divide that now by a. Well, a is just 1, and dividing by 1 doesn't really do anything. And in the Australian method, actually, at this point, I would look for, are there any common factors in either one of these sets of parentheses? And there aren't, because they both just have x as a leading term in each one of those sets of parentheses. So doing this problem doesn't really change it's not really different by using the Australian method. You would do this stuff in any method that you use to factor this trinomial. Where it really differs is when I have a leading coefficient that's not 1. And we would say, you've probably had a day in math that you've said factoring trinomials when a is not equal to 1. That's really what we're looking at today. So I do, not 156, 56. I need two numbers that multiply to give me negative 168 and add up to 13. Knowing that I want to add up to 13, I know that factors of negative 168 are going to be a positive and a negative. And knowing that I want to add up to a positive number, I want my positive number to be bigger. So I'm going to start with my negative numbers being the smaller numbers. And I'm just going to go through the list of factors until I get two numbers that add up to 13. If I take 168 and divide it by 2, I get 84. So I know that negative 2 times 84 would give me negative 168. But these add up to 82, not 13. So that one didn't work. I also know that it's a multiple of 3, and I know it's a multiple of 3 because I went 168 divided by 3. And it's 56, also because that's how I got negative 168. But I'm pretending I didn't know that. Those add up to 53. What about 4? And negative 4 and 42 would multiply and give me negative 168, but they would add up to 38. Notice how this list, the numbers are getting smaller, but they're not at 13 yet, so I need to keep going. It's not a multiple of 5, but it is a multiple of 6. And so that would be negative 6 and 28. And when I add those together, I get 22. So not there yet. It's probably a multiple of 7. Oh, it is. But if it wasn't, I would get a decimal here. But I know it is because I get a whole number. And then when I add 24 and negative 7, I get, sorry, brain fart a little bit. I get 17. I'm not at 13 yet, but I'm getting closer. Well, I know it's also a multiple of 8 because it's a multiple of 2 and 4. Well, that gives me a good idea that it is. That doesn't guarantee it. So 168 divided by 8 is 21. And when I add negative 8 and 21, I get 13. So my magic numbers here are negative 8 and 21. So in the Australian method, what we do is we put 3n in both of these. And I'm going to say it's 3n minus 8 times 3n plus 21. Now, that would be true, but if I looked at multiplying that, that would actually give me 9n squared. So I have too many n's, and I need to divide it by the leading coefficient a. Now, if everything works out, I'm going to have a common factor of 3 in one of these two sets of parentheses. And it turns out that I do in this one. 3 and 21 are both multiples of 3. 3n minus 8 doesn't have any common factors, but this has a common factor of 3. And it leaves me with n plus 7. Now, I'm dividing by that 3 for a reason that those now cancel out. So I get a final answer of 3n minus 8 times n plus 7. And just as a quick check, you can always do this. Check your first and last pretty easily with foiling. 3n times n would be 3n squared. 3n times 7 would be 21n. Negative 8 times n would be negative 8n. And we talked about negative 8 and 21 is 13. And then negative 8 and positive 7 is negative 56. So that works out. Okay, that's just a quick check. You don't necessarily have to. But if you're ever unsure at all, take a look at it. This one, a times c is negative 54. And b is negative 3. So I need factors of 54 that add up, factors of negative 54 that add up to a negative 3. Since they add up to a negative 3 and the factors are going to be one positive and one negative, I know that I want my negative one to be bigger in order for them to add up to negative 3. So some things that I can go through the whole list. I can go 54 divided by 2. Yeah, I knew that was going to happen. I hit the wrong button. 27. So we can say negative 27 and 2, but those add up to negative 25. A lot bigger than negative 3. It is a multiple of 3. I can go 54 divided by 3 gives me 18, so negative 18 and positive 3. Those are going to add up to negative 15. Getting closer, but we're not at negative 3 yet. 54 divided by 4, not going to work. 54 divided by 5, not going to work. 54 divided by 6 is 9. So I have negative 9 and positive 6. Those actually do add up to negative 3, so those are the numbers that I'm looking for. So we have k minus 9 and k minus plus 6. And again, in the Australian method, you'd say, okay, divided by 1 because the leading coefficient's 1, but that doesn't really do anything. Dividing by 1 doesn't change anything, and I have no common factors in my two sets of parentheses. So that's all I have. For the next one here, I want numbers that multiply to give me 7 times 15, which is going to give me 35. Is that negative 105? Let me just double check. I don't want to start off on the, okay, don't guess it. I don't want to start off on the wrong foot. Yeah, negative 105. And they add up to negative 32. With that being such a big number, then it's probably going to turn out that I won't have to take this list very far. I'm actually going to think about, well, it's a multiple of 3. 105 is a multiple of 3, and it's 35 times 3. And I want a negative here, and this is going to give me a negative and a positive. So let's say negative 35 and positive 3. When I add those together, I do get negative 32. So those are my magic numbers, negative 35 and positive 3. In the Australian method, we put the 7b in both sets of parentheses. And knowing that that's going to overestimate by a factor of 7, I'm going to divide by 7. And I'm going to put that negative 35 and positive 3 in the two parentheses. And it doesn't matter whether you put the plus 3 there and the negative 35 there. That part doesn't really matter. You can choose which one to put where. Now I'm looking for common factors. I notice that this one, 7 and 35 are both factors of 7. 7 and 3 don't have any common factors in the second one. So I'm going to get 7 times b minus 5, because if I distribute that, I get 7b minus 35, and 7b plus 3 in this one. And that's all going to be divided by 7. I'll cancel out those 7s, and I get factored out b minus 5 times 7b plus 3. And there we go. Next one, oh boy, that's a big one. We've got some stuff going on here. I need two numbers that multiply to give me, I can see maybe an easier way to accomplish this. I'm going to take this problem down a little ways by looking for any common factors in all three terms first. Okay, I notice that they're all factors of 5. So I'm going to factor out that common factor of 5 first. 7z squared plus 11z plus 4. I'm really going to love that I decided to do that, because that's going to make life a lot easier. And for the majority of this, I'm going to kind of forget about that 5. I'm just going to remember that it's there at the end, But I don't want to look for things that multiply to give me 700. I'd rather look at things that multiply to give me 7 times 4, which is 28, and that add up to 11. That's a lot better. Okay, that's a lot better. So things that multiply to give me 28. 2 times 14. But when I add those, I get 16. It's not a multiple of 3. It's a multiple of 4, though. 4 and 7. Oh, and 4 plus 7 is 11. So 4 and 7 are my magic numbers here. I'm going to have, in the Australian method, I want to say 7z plus 4 and 7z plus 7. And again, I'm off by a factor of 7, so I do want to divide it all by 7. Looking for common factors, 7 and 4 don't have any common factors, but 7 and 7 do. Lots of 7s going on. 7z plus 4 times 7 times z plus 1. And that 7 in the middle there is going to cancel out with that 7 at the bottom. And I'm going to get 7z plus 4 times z plus 1. Now there is something that I have to remember. This whole thing was multiplied by 5, as was this multiplied by 5. And so this is all multiplied by 5. Okay? And so that gives me my final answer right there. 5 times 7z plus 4 times z plus 1. Okay, next one, I take a quick look, and it doesn't look like I have any common factors, which, oh no, it's not that bad. But I'm looking for things that multiply to give me 4 times 24, which is 96. And they have to add up to negative 35. So the question is, how can I pick two numbers that multiply to give me a positive, but add up to give me a negative? And that's kind of a trick. It turns out that it turns out that both my numbers need to be negative, right? Because a negative times a negative is going to give me a positive, and is going to add up to give me a negative. So I need 96. I guess I had it already. It's multiple of 2. It would be negative 2 and negative 48. But when I add those two together, I get negative 50. So that's too big. So let's check 96 and 3. So negative 3 and negative 32. Those add up to give me negative 35, and that's what I was looking for. So let's go ahead and write it using our Australian method. Let's say 4n minus 3 and 4n minus 32. And I'm going to have to divide all that by 4. No common factors in the first one, but I do have a common factor of 4 in the second one. So 4n minus 3 times 4 times n minus 8. If I distribute that 4 in there, I'd get 4n minus 32. And I'm dividing it by 4. Those 4's cancel, and I get 4n minus 3 times n minus 8. And there we go. Okay, let's go ahead and turn the page and look at a couple more. Let's see, I know there's at least a common factor of 2 in this, and I'm going to say that there's probably a common factor of 6 in it. I know that 60 is a multiple of 6, and I know 36 is a multiple of 6. Let me check 102. Because if I can reduce this, it's only going to make my life easier. And it is. It's 17 times 6. So this is 10x squared plus 17x plus 6. That's going to make my life a lot easier taking out that common factor. So now I need two numbers that are going to multiply to give me 60 and add up to give me 17. Let's just go ahead and try some. Let's see. We have 2 and 30. It's going to add up to give me 32. I have 3 and 20, which is going to add up to 23. 4 and 15 is going to add to give me 19. 5 and 12. Ooh, there it is. 5 and 12 add up to 17. So, again, I'm going to put that 6 aside for now. I'm just going to know that it's going to be part of my final answer. And to set this up, I have 10x, plus 5, and 10x plus 12. And that's all being divided by 10. I do notice that the 10 and the 5 have a common factor of 5. I'm going to have to pardon the noise a little bit. That's 2x plus 1. And then the 10 and 12 have a common factor of 2. That's going to be 5x plus 6. And this is a special case here that I don't have a 10 that I got to bring out, but I got two things that multiply to give me 10. 5 times 2 is 10, and that's what cancels out with the 10 on the bottom. Let me get rid of this so I have a little more room. So at this point, I've canceled out my denominator, and so I get 2x plus 1 times 5x plus 6. The only thing I need to remember, I pulled the 6 out from the very beginning, so I got to bring that 6 back into play. And that's my final answer on that one. Last one of these, and then we'll look at something a little bit different. I want two things that multiply to give me 63 and then add up to 16. As you get better at these, you'll start to pick them out pretty quick. 63 is 7 times 9. 7 plus 9 is 16. So the numbers I'm looking for are 7 and 9. There are no common factors, which is good because I didn't have anything to divide by, because I was just dividing by 1, and so that's my final answer. Again, the better you get at these, the better you get at knowing your multiplication tables is really what it comes down to. The easier some of this becomes. Obviously, there are some of these hard problems, and they just take a little bit of time. Stick to the process, and you'll get there. The last little bit that we have to talk about is what we call difference of squares. And it's when I have a or something squared, and this can even be a quantity itself, minus, for difference, something else squared. It's only a binomial, but it's still a quadratic because we're going to have some variable squared, usually at the start, maybe in both places, and maybe even just at the end. But the key here is that they're being subtracted. And it turns out that this is equal to the first one plus the second one times the first one minus the second one. And really what this comes down to is somebody realized that as they had something that looked like this and they FOILed, they'd get a squared minus b times a plus b times a minus b times b, or b squared. And that these two things always canceled out in the middle. Okay, and so that's what really drives this idea that this is a factoring technique, because sometimes we don't really want to know that it's n squared minus 1. We know that the square root of n squared is n, and the square root of 1 is 1. So this really just becomes n plus 1 times n minus 1. Similarly, in the second one, The square root of b squared is b, and the square root of 36 is 6. So this is b plus 6 times b minus 6. The beauty with this is that it doesn't always have to be, it doesn't matter if you put the plus 1 first and the minus 1 second, it's multiplication. So it can be flipped around. Like this one, the square root, and I'll even write this, the square root of 4x squared is 2x, and the square root of 81 is 9. So I would get 2x, I could say minus 9 times 2x plus 9. On this one, I have 100m squared minus 169, and it turns out that 100m squared, the square root of that, is 10m, and the square root of 169 is 13. So this becomes 10m plus 13 times 10m minus 13. Go ahead and pause the video and try the last two problems. Hopefully you had a chance to get that done. I'm not going to make it take any longer than it has to. 5x minus 4 times 5x plus 4, and 11z minus 3 times 11z plus 3. Feel lucky when you get a difference of squares problem, because as long as you know what those square roots are, that problem gets very simple. Anyways, if you have any questions, put them over on the left. Otherwise, I hope you have a great day, and we will see you in class.